Hello students, how are you? As you know, we are doing standard integration techniques, and in today's lecture we will discuss about the homogeneous equation, and we will see that this homogeneous equation, that is 2.61, this is basically the general form of a homogeneous equation, and this equation is invariant under the Lie group that is given by equation 2.62. Now students, first of all we will check that this equation is invariant under the given Lie group, and then after that we will find the infinitesimals, and by using those infinitesimals we will find the canonical variables r and s. And what will be the benefit of the canonical variable? Definitely, when we substitute the values of these variables in our original homogeneous equation, then our equation will be converted into a separable equation, and that is easily solvable. Now students, let's start. First of all, this is the homogeneous equation that is given by this one, and this is invariant under the Lie group that is given by this. Now students, if you want to check the invariance of this condition, so you can write it as like dy bar divided by dx bar is equal to f of x bar is divided by y bar. As you know, the Lie group is given by x bar is equal to e raised to power epsilon x, and y bar is equal to e raised to power epsilon y. Okay, so here if you find the value of dx bar, then definitely it will become equal to e raised to power epsilon into dx, and similarly dy bar is equal to e raised to power epsilon into dy. And similarly, if we substitute these values in this equation, say this is equation number 1, then we will get e raised to power epsilon dy is divided by e raised to power epsilon dx, and that is equal to f of the value of x bar e raised to power epsilon x is divided by e raised to power epsilon y. And if we simplify it further, then we will get our original equation. So the given equation is invariant under the given Lie group. Now our next task is to expand, like this is the local form of a Lie group, and here these are the values of capital X and capital Y, and the other way of finding capital X and capital Y are basically this one, like partial x bar by partial epsilon at epsilon is equal to 0 is equal to capital X of xy, and partial y bar is divided by partial epsilon at epsilon is equal to 0 is equal to capital Y of xy. Now, as you know, x bar is equal to e raised to power epsilon x, and if you take the partial derivative with respect to epsilon, then it will become the same, like e raised to power epsilon x at epsilon is equal to 0 is equal to capital X. So if you substitute the value of epsilon is equal to 0, then you will simply get capital X is equal to x, and in the similar way you can find capital Y is equal to y. Okay, now that's why I have written here the value of capital X, that is simply x, and the value of capital Y, that is y, and these are the infinitesimals. Now the change of variables, the equations for the change of variables are actually these one that are written x rx plus y ry. Basically these are capital X of rx plus capital Y of ry, that is equal to 0, and capital X of sx plus capital Y of sy, that is equal to 1. Okay, now if you solve these equation by the method of characteristics, then you will get the solution of the form like these ones. Okay, and after that, where r and s are arbitrary functions of their arguments. Now choosing r and s such that here we can take the value of r is equal to y by x and s is equal to natural log of x. So if you want to find the value of x, then you can take exponential on both sides, and as you know, logarithmic function and exponential are opposite of each other, so they will be cancelled out with each other, and you will get the value of x is equal to e raised to power x. And here you can find the value of y, and here you will substitute simply e raised to power x, and you will get the change of variables by equation number 2.64. now simply you will take the differential, like you want to find the value of dy by dx, because now your next task is to simply use these values in your original equation that is given in equation number this was equation number 2.61. okay, and after simplifying it further, you will get the value of s prime, or you can say ds by dr, that is equal to 1 by f of r minus r, and this is the separable ordinary differential equation. Okay, or you can easily solve it. Now let's have a look at a particular example. You can see that this is basically a homogeneous equation. The other way of checking that whether a function or equation is homogeneous is that you simply replace the variables with the, like, x is equal to tx or y is equal to ty, and if you can take t as a common and they will be cancel out with each other and you get the previous equation, then definitely that will be homogeneous one. Okay, now here they have just substituted the values of f of r and r, and they get this equation. And if you take dr on the right hand side, then it is a separable equation, and you can easily get its answer. Okay, now student, this is all about this lecture where I have explained the procedure of converting a homogeneous equation into a separable equation. In the coming lectures I will try to explain these examples, like we will apply the whole procedure. Like here I have just converted the given equation in a general way, but we will see that how we can apply the whole same procedure on our example. Okay, thank you so much. This is all about this lecture.